Now the integration of dx equals to x plus c. This is the formula. You can calculate like this: dx by dx equals to 1. So integration 1 into dx will be x plus c. Third, d sin x by dx is equal to cos x. So integration of cos x dx will be sin x plus c. Fourth, integration of d cos x by dx equals to minus sin x. Hence integration of sin x dx will be minus cos x plus c. 5. Integration of d tan x by dx equals to sec square x. So integration of differentiation of tan x by dx, that is d tan x by dx equals to sec square x. So integration of sec square dx will be tan x plus c. D cot x by dx equals to minus cosec square x. So integration of cosec square dx equals to minus cot x plus c. 7. Differentiation of sec x by, that is d sec x by dx equals to sec x into tan x. So integration of sec x into tan x will be equal to sec x plus c. D cosec x by dx equals to minus cosec x into cot x. So integration of cosec x into cot x will be equal to minus cos x plus c. Similarly, d e to the power x by dx, that is differentiation of e to the power x. It can also be written studied as equals to e to the power x. So integration of e to the power x dx equals to e to the power x plus c. D log x by dx to the base e, log is at base e, equals to 1 by x. So integration of dx by x equals to log x plus c. Now we can solve some problem related to integration. Find the equation of given function tan x, cot x, sin squared x and cos squared 2x. Let integration is I, that is I equals to integration of tan x dx equals to integration of sin x by cos x dx, equation 1. Again let y equals to cos x, then dy by dx equals to d cos x by dx equals to minus sin x. This implies dy equals to minus sin x into dx, or sin x dx is equals to minus dy. Now I equals to integration of sin x dx by cos x. So we can write integration of minus dy, because sin x dx is equal to minus dy and cos x equals to y. So minus dy by y. So minus of integration dy by y, and this will be equals to minus log y plus c, and put the value of y, so minus log cos x plus c, or equals to log cos inverse x cos to the power minus 1 plus c equals to log 1 by cos x plus c, or log sec x plus c. Answer. Thus integration of tan x dx equals to log sec x plus c. Second, I equals to cot x dx. We can write it as integration of cos x by sin x dx. Take y equal to sin x, then dy by dx equals to d sin x by dx equals to cos x. This implies dy equal to cos x dx. Now again I equals to integration of cos x dx by sin x equals to, because cos x dx equals to dy and y equals to sin x, so we put this value cos x into dx equals to dy and sin x equals to y, so dy by y, and we know that integration of dy by y equals to log y, so we can write log y plus c, or log, put the value of y, the log sin x plus c. Answer. Similarly, I equals to integration of sin square x dx. Integration of, now sin square x is equal to 1 minus cos 2x by 2 into dx, or this can be written as integration 1 by 2 minus cos 2x by 2 into dx. Integration of 1 by 2 dx minus integration of cos 2x by 2 into dx. or 1 by 2 into integration dx minus, because constant can be uh, 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 outside the constant can be moved outside the integration. So 1 by 2 integration dx minus 1 by 2 integration cos 2x dx. Now integration of dx is x, so we have x by 2 minus 1 by 2 into, and now integration of cos x cos 2x equals to sin 2x by 2 equals to 1 by 2 common, taking common, so we have 1 by 2 into x minus sin 2x by 2 plus c. This is integration on constant. 4 I integration of cos square 2x dx, integration 1 plus cos 4x by 2 into dx, integration 1 by 2 plus cos 4x by 2 into dx, integration 1 by 2 dx plus integration of cos 4x by 2 into dx equals to 1 by 2 integration dx plus 1 by 2 into integration cos 4x dx equals to 1 by 2x, because integration of dx equals to x, or integration of cos 4x equals to sin 4x by 4 plus c. This is the answer. One question: the velocity of a particle varies with time. V equals to 2t plus 12t square. What will be the displacement covered by the particle? We have given V equals to 2t plus 12t square. Now displacement is velocity is given as dx by dt. So we can write dx by dt equals to 2t plus 12t square. So dx equals to 2t plus 12t square into dt. Now integrating both sides, integration of dx, integration of 2t plus 12t square dt dt. Now integration of dx equals to x, because here integration constant, there will be both side integral constant which will be cancelled, so we are not writing here integrational constant. This imply x equals to integration 2t dt plus integration 12t square dt. Now equals to 2 into integration of t dt equals t square by 2 plus 12 into integration t square dt tq by 3 plus c, and t square plus 4tq plus c. Answer. There is no need to write an integrational constant here. Example: integrate y equals to 1 by 5x plus e to the power minus 5x plus sec square 4x. So we have I integration of y dx. So you put the value of y, integration 1 by 5x plus e to the power minus 5x plus sec square 4x ds. Now each term can be integrated separately. So integration of dx by 5x plus integration e to the power minus 5x dx plus integration of sec square 4x using all formula. Integration of dx by x is equal to log x. So 1 by 5 log x. 1 by 5 is constant, so it comes out of the integration. So 1 by 5. Now integration dx by x is equal to log s. Now integration e to the power minus 5 by dx will be equal to e to the power minus 5x by minus 5 plus integration of sec square 4x dx will be equal to tan 4x by 4 plus c. This is the answer. Now definite integration. We have y equals to fx, then dy by dx, that is differentiation of y, equals to dfx by dx. After differentiating, another function is achieved, that is fx, or this can be written as fx or f dash x or gx. So dfx equals to fx dx. Taking integration dfx equals to integration fx dx. So integration of fx dx equals to fx plus c. Integrating it from a to b, then integration a to b fx dx is equal to integration of fx plus c from a to b, where a is the lower limit and b is the upper limit. Now putting the value of a and b in the limit, so integration fb plus c minus fb fa plus c. So fb plus c minus fa minus c, c will be cancelled, so we have fb minus fa. So in definite integration there is no use of integral constant. For example, integration of x square plus x cube dx. We can integrate it like integration 1 to 2 there is here a limit is given 1 to 2, lower limit is 1 and upper limit is 2, x square dx plus integration 1 to 2 x cube by dx. Now when we integrate, this will become x cube by 3 and we have to put the limit 1 to 2. Now this integration will be x4 by 4, put the value limit 1 to 2. 1 by 2 we have to calculate the limit value. Now we know that the upper limit minus lower limit, so here we can put upper limit 2 ka cube minus 1 ka cube and 1 by 3 is common, so 1 by 3 is 2 ka cube minus 1 ka cube, and in this case 2 ka power 4 minus 1 ka power 4, so 2 ka power minus 1 ka power, because 1 by 4 is common. So we have putting the value 1 by 3 into 8 minus 1 plus 1 by 4 into 60 minus 1, solving we get this answer. Similarly, we can calculate 2 to the power integration 2 to 3 t by t square minus 1 by t cube dt. Integration 2 to 3 t to the power minus 2 and minus t to the power minus 3 dt. Now we can integrate this 2 to the power 3 t to the power minus 2 dt minus 3 t to the power minus 3 dt. The first integration will be t to the power minus 2 plus 1 divided by minus 2 plus 1. Using integration x to the power n dx, we have to use that formula, and this will become out to this minus integration same again equal to t to the power minus 1 by minus 1 in the limit 2 to the 3, lower limit 2 upper limit 3 minus t to the power minus 2 to the limit 2 to 3. Now minus will take out from the limit value, and t to the power minus 1 to the power 3 1 by 2, here 1 by 2 comes out of the bracket, so minus minus this will be plus 1 by 2 into t to the power minus 2 limit 2 to the 3. Now put the value here minus upper limit minus lower limit, so we have to put t the value of t as 3 minus value of t as 2, so t to the 3 minus t, that is t to the power minus 1, that is 3 to the power minus 1 minus 2 to the power minus 1. Again in this 3 to the power minus 2 minus 2 to the power minus 2. Similarly solving this finally, and we get the answer like this 7 by 72 answer. Next is 0 to pi sin square dx. Now we know that sin square x is equal to 1 minus cos 2x by 2. So we have put the value, we put the value of sin square x 1 minus cos 2x by 2 dx and differentiate. Now this can be 1 by 2 can be taken out of integration, so 1 by 2 equation limit is given 0 to pi 1 minus cos 2x dx, or 1 by 2 0 to pi dx minus 0 to pi cos 2x dx, or 1 by 2 under bracket. Now integration of dx is x and limit is 0 to pi, here integration of cos 2x is sin 2x by 2 0 to pi. Putting and solving, finally we get the answer at pi by 2. Similarly we can solve many problems like this. Next example is 0 to t by 6 integration cos omega t dt in the limit 0 to t by 6. We can solve directly, because cos omega t dt we can write it directly integration sin omega t by omega 0 to t by 2, put 1 by omega comes out of bracket, so sin omega, and now put the value of t by 6 minus sin omega I into t, so value of 0, so 0. Now 1 by omega into sin 2 pi, omega equals to 2 by t, 2 pi by t, so 2 pi by t into t by 6 minus sin 0, or sin 0 equals to 0. here 1 by omega. Now tt cross and this will be pi by 3. So sin pi by 3 equals to 1 by, or again put omega, the value of omega 2 pi by t sin pi by 3, or equals to t by 2 pi into root 3 by 2, because sin pi by 3 equals to root 3 by 2. So we have root 3t by 4 pi as a answer. Next example. The velocity of a particle varies with time as v equals to t plus 12 t square plus 12 t meter per second. What will be the displacement in time between t equals to 2 second and t equals to 4 second? Given v equals to t plus 12 t plus 12 t square, so we can write v equals to dx by dt, t plus 12 t plus 12 t, and hence dx will be t plus 12 t plus t 12 t square dt into dt. Now integration taking limit x1 to x2 dx equals to 2 to 4 t plus 12 t plus 12 t square dt. So x2 minus x1, this will be the displacement, equal to 0 to 4 t dt plus 2 to 4 12 t dt, 0 to 4 12 t square dt. So x will be t square by 2, 2 to 4 12 t square by 2, 2 to 4 equals to 12 t cube by 3, 2 to the 4. Solving this, finally we get 302 meter answer. Now the next topic is kinematical equation for constant acceleration. Here we have a equals to constant. So by definition of a, that is acceleration, a equals to dv by dt. Differentiation of velocity of with respect to time gives acceleration. So a equals to dv by dt. Now we can write dv equals to a dt. So integrate it from v naught to v dv and 0 to t. That is, this represent velocity at time 0 and this represented velocity at time t. The integration dv is equal to 0 to t a dt, because a is constant, it comes out of the integration, the 0 to t dt. Now after integration, the value will be v in the limit v naught to v, and this value is t in the limit 0 to t. Now put the limit value v minus v naught equals to a into t minus 0 equals to at. This gives v equals to v naught plus at. This is the equation 1. This is the first kinematical equation. Now the second. Further we have v equals to dx by dt. Please note that the velocity is the differentiation, time differentiation of displacement, that is dx by dt. So dx will be equals to v dt, integrating both sides within the limit. So x naught to x integration dx equals to 0 to t v dt equals to 0 to t, because we have calculated v equals to v0 plus at. So v0 plus at dt equals to 0 to t v naught dt plus 0 to t at dt. After integrating dx, this will come to x and the limit x naught to x. Its integration, because this is constant, it comes out of the, and dt, the integration of dt is t. So here v naught into t in the limit 0 to t, and here a is constant and the integration of t will be t square by 2. So here a into t square by 2 0 to t. This implies x minus x naught equals to v naught into t minus 0 plus a by 2 into t square minus 0 square. X minus x naught equals to v naught t plus 1 by 2 a into t square, or x equals to x naught plus v naught t plus half a t square. This is the equation 2. And displacement s will be equal to x minus x naught v naught t plus half a t square. Now the third. Now we can write a equals to dv by dt equals to dv by dx into dx by dt equals to v into dv by dx. and v dv equals to a dx. This implies integration v dv in the limit v naught to v x naught to x a dx. This implies v naught to v dv equals to, because a is constant, so it comes out of the integration x naught to x dx. This will like v square by 2 v naught to v a into x naught to x 1 by 2, putting the value, limiting value, the 1 by 2 comes out of the integration. V square minus v naught square equals to a into x minus x naught. V square minus v naught square is 2a into x minus x naught, or v square minus v naught square equals to 2a, because x minus x naught is the displacement. So here is, so v square equal to v naught square plus 2as, or it can be written as v naught square plus 2a into x minus x naught. That is the answer.